Hi, I'm Ken Rule, Senior Applications Engineer for Expand Machinery. Welcome to another Expand Machinery Tip of the Month. Today we will cover tool nose radius comp for turning and milling on a lathe with live tooling. The G codes for cutter comp are G41 and 42. If you draw an arrow pointing up and add two circles tangent to the line, the circle on the left will be G41 and on the right will be G42. These represent the side of the material that the tool is cutting for both a lathe tool or an end mill. You can hold the paper with the arrow pointing in the cut direction and it will indicate the G code necessary depending on the side of the material the tool is working. If we face the arrow to the left, it will be in the direction of turning tools in a lathe. If we project the tools onto a part profile, it will show that G42 is used for OD turning and G41 for ID boring. Notice the actual program point of the turning and boring radiuses are not even on the tool. They are the intersection of the tangent, face, or turn created by the radius. This tangent point is what we use to set the tool offsets. To touch off an OD turning tool, we turn a diameter and measure it for the X offset and create a face and measure it for the Z offset. The intersection of these tangent lines is the actual program point. When creating a turn diameter or a face, no cutter compensation is necessary. But if we do a chamfer, angle, or radius cut, the tool will not cut at the print dimension unless we compensate for the program point. To do this compensation on a turning or boring tool, we need to let the control know where the program point of the radius is in relation to the cut. The control has a tool nose radius page that allows you to place the radius in a place for each tool. Along with the radius offset, the control will have another input called nose or point. This is what you use to tell the control how to compensate for a radius. The matrix that is used to name these points have 9 numbers that describe the point. An OD turning tool would use point 3. A boring bar would use point 2. A back turning tool would use point 4. And a back boring tool would use point 1. The other points are very rarely used, except for 0 and 9. These 2 points are used to describe the center of a driven end mill side cutting on the G19 side or G17 face. Most controls will default to the center of the radius if you leave the nose at 0. Other controls, like those used on the GenTurn CS and NCY machines, require a 9 to activate the cutter comp on an end mill when you're side cutting. I hope this helps your understanding the tool nose radius compensation on a turn mill lathe. I will see you next month for another Expand Machinery Tip of the Month.